Hello, children. Good morning. This is the very first class of CBSE Class 10 of Mathematics. Welcome to the world of real numbers. Yes, before we start to understand what real numbers are, let's try and understand what kind of numbers were introduced starting from the beginning. Natural numbers. These are nothing but the counting numbers starting from 1. It goes on till infinity, right? Then Then came the barb of this whole numbers. Whole numbers has 0, 1, 2, including 0 and all the positive numbers. So you know who contributed 0? It was the Indian mathematician Brahmagupta. Sometimes they make fun of Indians. What is their contribution in mathematics? 0. But yes, 0 is very important. If you realize when we subtract a number with itself, we get a result 0. When we divide a number with itself, yeah, we get a remainder 0. It's a very important contribution. Yes. Now, barb of whole numbers, then human beings discovered something called as integers. For now, natural numbers I'll denote as n, whole numbers as w, integers, either you call it I or Z. Okay. So this had all the negative numbers, 0 and positive numbers. And then came a barb of integers that's called rational numbers. Yeah. Rational numbers not just has discrete values like 1, 2, 3, or -1, -2, -3. It has even decimals, fractions. So anything which can be expressed in the form of P by Q. Q should not be equal to 0, okay? Otherwise, it's an error in math. It is undefined. Yeah. So what is a rational number? A number which is of the form of P by Q. Q should not be equal to 0. Both P and Q can belong to integers. For example, -3 by 5. Yes, it's a rational number. 0.6. 0.6 also is rational because I can express it in the form 6 by 10. How about just 0? Oh, yes, it is rational. It can be expressed in the form of 0 by 1. How about -5? It is -5 by 1. Okay. All the numbers which can be expressed in the form of P by Q are rational numbers. But there's a difference between rational numbers and fractions, okay? Fractions are just positive, whereas rational numbers can even have negative signs because as I told, P and Q should belong to integers. Okay. And there was one more family. Okay. Let's call them their cousins. Let's call them their cousins. It's irrational numbers. So I'll do it on the next page. Irrational numbers are something which cannot be expressed in the form of P by Q. They neither terminate nor do they recur. At least this 0.333333, even though it is recurring, right? I can still express it in the form of 1 by 3. I can still express it as a fraction. But this irrational numbers, I can't, neither do they recur, nor do they terminate, nor do they have a pattern. For example, pi, 3.141528. See, there's no end, there's no recurring pattern. Then Napier's constant E, golden ratio phi, square root of 2, 1.414, blah, 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 blah. It neither terminates nor does it recur. So such numbers are called irrational numbers. So what are real numbers? It's a family of rational numbers and irrational numbers. Okay, even though these irrational numbers are weird, but still they all come under real numbers. When you get to 11th grade, you will learn another category, children. That's called imaginary numbers. Yeah, imaginary numbers are those which do not exist in real. For example, square root of -4. Can we find out square root of a negative number? Not at all. In 11th grade, you will learn it as 2 iota. Okay, now let's not get into that. So this was a brief introduction to what we are going to learn about. Now, first, let's start with the fundamental theory of arithmetic. You know what it says? It says every composite number can be expressed as a product of primes. By the way, what are prime numbers? Those जिनको कोई नहीं काट सकता, कोई भी नहीं, except for themselves and one. For example, 5. If you want to see who all can cut it, who all can divide it, it's just 1 and himself. Whereas composite number can be expressed as product of primes, and this factorization is unique except for the order of its prime factors. What the hell does this mean? Okay. For example, all of you know 8190 is a composite number. So that means not just 1 and 8190, even other numbers are its factors. For example, 4095s are 8190. 4095, hey, that's a multiple of 3. So 3 into 1365. This one, again, it goes with 3 stable. This one, again, it goes with 5 stable. 91, again, it would go with 7 stable. So as you can see, this 8190, yeah, it can be expressed as product of prime numbers. 2 into 3 square into 5, and maybe the 91. 91 continues with 7 stable. 7 13s are, okay? Didn't I express this 8190 as product of primes? Yes, even powers are there. For some numbers, the powers are there. All right. Order really doesn't matter. You want to write 13 first or 7 first, that really doesn't matter. Okay, so that's why they've written this word, except for the order of its prime factors. Right? So we will be using this method of prime factorization to find HCF and LCM. Right? So now let's talk about HCF. Suppose I give you, let's say 2 numbers or 3 numbers, 18, 36, 72. I want to find the highest common factor. Which number will divide all 3 of them, leaving me a remainder 0? Highest common factor. So now we will start making a factor tree, okay? 1 18s are 18. 1 to by default it will come for all. 2 9s are 18. 2 is prime number, so let it keep quiet. This 9 is 3 3s are 9. So, 18 I got it as 1 into 3, 2 into 3 square. Let's talk about 36 now, okay? 136 are 36, that doesn't matter. Actually, you don't even have to write this. Next, 2 18s are 18, that's 2 9s are 9, that is 3 3s are. Okay, so did you notice that you have 2 square into 3 square? Yes, these are the prime factors. All right, last number 72. Yeah, this fellow's prime factors, let me find. 172s are, then I'll go with 2 stable. This is again 2 stable. This is again 2 stable. So I'm getting 2 cube into 3 square. Now I shall talk about highest common factor. So you're noticing 1 though by default. Okay, we'll not take that. 2, yes, it's present everywhere, but we should take which is the least power out of that. Yes, so it's 2 power 1. Okay. Amongst 3 square on top, 3 square here, 3 square down, everybody has 3 square as a common factor, and that's the least power of 3 present. So 3 square is 9, 9 into 2, 18. Guys, 18 is the highest common factor of 18, 36, and 72, which means I can divide all these numbers with 18. Where the hell do we use the concept of highest common factor? for simplifying. Suppose you have a fraction 36 by 72, right? You know that, or let's say 18 and 72. You know that 18 is the highest common factor of it. 18 ones are, 18 fours are. So you are finishing your simplification quickly. Okay, so this is the concept of HCF. Now let's talk about the concept of LCM. For LCM, what we do is we take the highest power common. For example, amongst 2 square and 2 cube, I must take 2 cube out, least common multiple. And 3 square, 3 square, 3 square, yeah, that's the highest power. Let's say we had another one more number, let's say 5. We would have invited Mr. 5 also. Okay, we would have invited him. Let's say here an extra 7 came. We would have invited him as well, even though it was not common in the other numbers. Okay, so for least common multiple, we have to invite everybody. And amongst common ones, we should invite the one with the highest power. So 8 into 9. 72 is the LCM of 18, 36, and 72. Now, where do we use the concept of LCM? Addition and subtraction of fractions. For example, you want to add, let's say, some 2a by 18 plus some 3a by 72. You would have taken the least common multiple whenever we add or subtract fractions. 72. 18 fours are, so 2a fours are 18. 72 ones are, so 3a ones are 3a. Right? I hope you all understood. Highest common factor we use for factorization. Least common multiple we use in addition and subtraction of fractions. Okay. For today's class, this should be enough. In the next class, we shall do the first exercise of your NCERT textbook. Thank you.